We'll now look at solving systems of equations. Essentially, a system of equations is just a set of equations that we're solving all at once. Usually these are going to need to involve more than one variable. As an example, we have something like this: y equal to 6x minus 11 and negative 2x minus 3y equal to negative 7. And we want to find something that satisfies both of these equations at once. And there are a couple of ways to do this. Right now we're going to look at a method called substitution. And the fact that it's called this should give you some clue that we're going to be doing some substitutions. And we are. You'll notice this first equation says y equal to something. So in my second equation, I'm going to change it slightly so that I have negative 2x minus 3. And instead of y, I'm going to write what we know y is equal to, 6x minus 11. Whenever we do that, now I have an equation in a single variable that we should already know how to deal with. Distributing, negative 3 times 6 is negative 18, and negative 3 times negative 11 is 33. Negative 2 minus 18 would be negative 20x, plus 33 equal to negative 7. I can subtract the 33 from both sides. That gives me negative 20x equal to negative 40. And then dividing gives me that x is equal to 2. So now I have half of my answer. I still need to know what y is equal to. However, that first equation makes it very easy. I know that y is equal to 6 times x, which we just said was 2, minus 11. So 6 times 2 is 12, minus 11 would be 1. So now I have my solution as x equal to 2, y equal to 1. And you'll often also see this written as an ordered pair, 2, 1. Let's do another example. 2x minus 3y equal to negative 1 and y equal to x minus 1. This time I'm going to start with the first equation, 2x minus 3, and instead of y, I'm going to write what we already know y is equal to, x minus 1. And then that's equal to negative 1. So this is 2x minus 3x plus 3 equal to negative 1. Negative 2 minus 3 would be negative 1, so negative x plus 3 equal to negative 1. If we subtract 3, I get negative x equal to negative 4, so x is 4. We still need to know y, but y is x, which we just said was 4 minus 1, so y is equal to 3. So I now have my answer, 4, 3. And these two examples were actually quite nice because we already had one of the equations that said y equal to something, but oftentimes that's not what we're given. In this case, we don't have y equal to something or x equal to something, so it's not a good idea we can't use the same method that we were using before. So essentially this requires just one extra step of taking one of the equations and solving for a variable. Which equation you pick and which variable you pick honestly doesn't matter, you'll get the same answer at the end. However, it kind of does matter. If I were to solve the first equation or the second equation for x, I would have to deal with fractions throughout the rest of the problem, and nobody really wants to do that. So the best thing to do is to solve for one of the variables that has a coefficient of 1 or negative 1. As an example, I'm going to solve the first equation for y. So in order to do that, I'll add 4x to both sides and get y equal to 6 plus 4x. And now I can use the same method I was before. I can take my second equation that says negative 5x minus y, which we just said was 6 plus 4x, equal to 21. Make sure you distribute the negative sign. So that's negative 6 minus 4x equal to 21. Negative 5 minus 4 is negative 9x minus 6 equal to 21. I can then add 6 to both sides and get negative 9x equal to 27. And then dividing gives me that x is equal to negative 3. I can now go back to my other equation. Y is equal to 6 plus 4 times x, which we just said was negative 3. And 4 times negative 3 is negative 12, so y is equal to negative 6. So I now have my answer, negative 3, negative 6. So let's do one more example like this. Here, I have negative 7x minus 2y equal to negative 13 and x minus 2y equal to 11. Like we said in the last example, we really want to pick an equation and a variable that has a coefficient of 1. So I'm going to solve my second equation for x. We'll do that by adding 2y to both sides. So now I have x equal to 11 plus 2y. If I go back to my first equation, negative 7 times x, but I just said I know what x is. It's 11 plus 2y. Minus 2y equal to negative 13. That now says negative 77 minus 14y minus 2y equal to minus 13. Well, adding negative 14 minus 2 is negative 16y. I can then add 77 to both sides. That leaves me with negative 16y on the left, and on the right, negative 13 plus 77 is going to be 64. Dividing by negative 16 then gives us the answer of negative 4. So that's now y. I can then go back to my other equation that says x is equal to 11 plus 2 times y, which we just said was negative 4. So x is 11 minus 8, or x equal to 3. So my answer is 3, negative 4. In general, when we write these in ordered pairs, we want to write x comma y. If for whatever reason you don't use the letters x and y, then just keep them alphabetically. If you have a's and b's, then a comma b, m and n, m comma n. Like I said, as long as things stay in alphabetical order.